Hello everyone and welcome back to our subject Calculus 3. In today's video, we'll be talking about a new topic entitled higher order partial derivative. So when you could still remember our discussion in Calculus 1, we have there a topic also that involves higher order derivatives like first derivative, second derivative, third derivative, and fourth derivative. So this time in partial derivatives, we can also have higher orders, and we'll start with the notation. The notation of higher order partial derivative could be represented by a tree diagram. Let's say, for example, a function like function x comma y, and the requirement is to find the first partial derivative of this function. So in other words, we could represent this in two like f sub x and f sub y. So f sub x here represents the first partial derivative of the given function f of x comma y. So f sub x and f sub y. And then this first partial derivative could be derived once more partially, and that will be equal to the partial derivative of x with respect to x and the partial derivative of x with respect to y. And also, the first partial derivative of f with respect to y will be further be differentiated partially, and that will be f of y sub x and f of y sub y. So this is the tree diagram of a function that is composed of two independent variables. So the first column here, f of x and f of y, this is what we call the first order partial derivative. So in other words, yan po yung kagaya dati ng tinatawag natin na first derivative. So this time, tinatawag po silang first order partial derivative. And here in the second column, these f sub x, f sub x sub y, f sub y x, and f sub y y, call them as second order partial derivative. I hope you got the point that whenever you have the first partial derivative, you can derive that once again with respect to the independent variables x and y, and that will become f sub xx and f sub x sub y. While if you derive partially the given function with respect to y in the first order, you can further differentiate that one partially, and that will be f sub y sub x and f sub yy. So other books also use different notation aside from this, but for the purpose of consistency in our video lesson, I'll be using this notation f sub x and f sub y only. So we'll have here a first example. In the first example here, given f of x comma y is equal to x cubed plus 4x raised to the 5th power, y cubed plus 5y raised to the 4th power. The requirements are find all second order partial derivatives. To find the second order partial derivative, of course, we'll have first the first order. So it is better for us to have a tree diagram here. So the given function is a function with two independent variables. So we can write here as what is the value of f sub x, and here what is the value of f sub y. This is the first order. With respect to x, the answer will be 3x squared plus hold y cubed as a constant, and we will derive 4x to the 5th. That will be 20x raised to the 4th power y cubed. And now here in f sub y, we will derive the given expression with respect to y, and the first expression is x cubed, so that will become 0 because that will be considered as a constant, and the derivative of the constant is 0. The second expression will be 4x raised to the 5th power y cubed, and that with respect to y, we'll consider 4x raised to the 5th power as a constant, and then we'll multiply by the derivative, the partial derivative with respect to y, which is 3y squared, plus the third term 5y raised to the 4th, the partial derivative of that will be 20y raised to the 3rd power. So simplifying, this will be equivalent to 12x raised to the 5th power y squared plus 20y cubed. So here in the first level, those are what we call first order. Now we'll move on to the second order partial derivative. This function, we can derive this once again with respect to x and with respect to y. So that will be f sub x and f sub x with respect to y. So this time we'll be using this function and not the original function because this will be the second order. So what is the derivative of this partially with respect to x? That will be equal to 6x plus, that is with respect to x. And here in the next term, the answer will be 4 times 20, so that will be 80x raised to the third power y cubed. Here with respect to y, the first term is 3x squared. We do not have any variable y here, so this will be considered as a constant. And the derivative of this first term will become 0. So the second term will be constant po yung may x, so 20x raised to the fourth power times the derivative with respect to y, so it will be 3y squared. And simplifying, this will be equivalent to 60. 20 times 3 is 60. 60x raised to the fourth power y squared. So this is now the value of f sub yy, and this is the value of f sub xx. I'm sorry, this is the value of f sub xy. And also, this expression, we can find the value of f sub y with respect to x, and then also with f sub y with respect to y. Here in f sub y sub x, what is the partial derivative of this with respect to x? So with respect to x, this is equivalent to 60, 5 times 12 is 60, x raised to the fourth power y squared plus 20y cubed, and that will become 0. There is no x variable there, so the answer is 60x raised to the fourth power y squared. However, in f sub yy, here lastly, we'll have 12x raised to the fifth power times the derivative with respect to y, that is 2y, plus with respect to y, so we have here 60, 20 times 3 is 60y squared. Okay, so finally we will have here 24, 12 times 2 is 24, 24x raised to the fifth power y plus 60y squared. So this is our final answer. This final two answers here, okay, I will color them in magenta. This is what we call the second order partial derivative. And here in the first column, we call them first order partial derivative. So, did we answer the requirement in the given problem? The answer is yes, because we all found out the second order partial derivatives of this given function. Here in the second example, we have given a function f of x comma y equals to the ln, or the natural logarithm of the quantity 3x minus 4y plus 1. The requirements: find all second order partial derivative. Before we can get the second order partial derivative of the given function, of course, we will have the first order first. Okay, so we will find first f sub x and f sub y. So this function, we'll find first f sub x and then f sub y. So f sub x is equal to the ln. So ln of u. What is the derivative of ln of u? So I will write here at the bottom, different color maybe. So what is the derivative with respect to x of ln of u? So that is 1 over u du dx. In calculus 1, you remember this one. So in this expression, inside the parentheses, this will be represented as our u. Okay, so if that will be our u, then our u here will be 3x minus 4y plus 1. And what is the partial with respect to x of u? With respect to x, that will be equal to 3. Okay, and what is the partial of our u with respect to y? With respect to y, that is equivalent to negative 4. So that's the answer. With respect to x is 3 because 4y and 1 will be considered as a constant and all of their derivative will become 0. And with respect to y, 3x and 1 will become constant, all of them will become 0, so we'll be retained with negative 4. Okay, we will apply that here in differentiating f sub x. So in other words, this will be equal to 1 over u du dx. 1 over u, our u is what? 3x minus 4y plus 1 times the partial derivative of u with respect to x, which is 3. So f sub x now will become 3 over 3x minus 4y plus 1. Okay, so this is now the equivalent value of f sub x. F sub y, on the other hand, we'll be using here 1 over u times the partial of u with respect to y. And that is equal to 1 over u, and our u is 3x minus 4y plus 1 times the derivative of our u with respect to y, which is negative 4. Okay, so the answer will be negative 4 all over, multiplying the two factors here. This will become 3x minus 4y plus 1. Okay, so this is the equivalent value of f sub y. These answers here are not yet the answer in the requirement because this is first order only, and the requirement here is second order. In other words, we will get again the partial derivative of this f sub x and then f sub y. The requirement in our given problem, we are required to find the second order. So we will derive again these expressions with respect to x and with respect to y. So the first job is f sub x with respect to x, and then f sub x with respect to y. So what is the partial derivative of this with respect to x? First step is to rewrite the expression in exponential form as 3 times 3x minus 4y plus 1 raised to negative 1. So constant po yung ating 3. And with respect to x, this will become chain rule once again. This will become negative 1 times the inside function. The inside function is 3x minus 4y plus 1 raised to negative 2 times the derivative of the inside function with respect to x, which is 3. So finally, f sub x is equal to negative 9. Okay, we have here a negative from the negative 1. That will become negative 9 times 3x minus 4y plus 1 raised to negative 2. And finally, the answer will become negative 9 all over 3x minus 4y plus 1 raised to 2. So with respect to y, from this step, so with respect to y, this will become 3 times negative 1 times 3x minus 4y plus 1 raised to negative 2 times negative 4. This negative 4 came from the derivative of the inside function with respect to y. That will become negative 4. So the answer will be 12 times, that will become 12 because you have negative 4, negative 1, so the long positive, the long negative, so that will become positive, and 3, so that will become positive 12 times 3x minus 4y plus 1 raised to negative 2, or if you will write that one in exponential form, that will become 12 over 3x minus 4y plus 1 raised to 2. And then our next job is to find f sub y with respect to x and f sub y with respect to y. So we will write first negative 4 times 3x minus 4y plus 1, following the same process of this one. This will be equal to negative 4 times the derivative of that will become negative 1 times the inside function 3x minus 4y plus 1 times with respect to x. That will become 3. I'm sorry, we have here an exponent of negative 2 because negative 1 minus 1 is negative 2. Okay, times 3. So this will be equivalent to 12 times 3x minus 4y plus 1 raised to negative 2. Or, if you rewrite that one in exponential form, this will become 12 over 3x minus 4y plus 1 raised to 2. And lastly, f sub y will be equivalent to negative 4 times negative 1 times 3x minus 4y once again plus 1 raised to negative 2. This time, what is the partial derivative of this inside expression with respect to y? That is negative 4. So the answer is negative 4, negative 4, negative 1. So that will be negative 16 times 3x minus 4y plus 1 raised to negative 2, or this will be equivalent to negative 16 all over 3x minus 4y plus 1 raised to positive 2. That's the second order partial derivative of this given function. So I hope you understand, and see you soon on the next video.